In this problem, we have catechol reacting with formaldehyde and acid. We are asked to predict the products, and to do this, I want to follow a mechanism. So we need to first identify what the hell kind of reaction would occur. Well, formaldehyde is an aldehyde and ketone, so I suspect some sort of aldehyde and ketone reaction. In the presence of acid, that kind of verifies this thinking, because we know that for nucleotide addition reactions, we need an acid catalyst. We also have a source of OH, which is an alcohol. We know that an alcohol reacts with an aldehyde or a ketone to make an acetal. And here we have both, so I suspect through logical reasoning that we are going to get a cyclic acetal. So let's draw the mechanism for that here before we predict the product. So I'll start right here. We have formaldehyde. We know that we have to activate the aldehyde before it can react with catechol. So we're gonna just take some acid from solution. So that's H2SO4 right there. That's gonna pick up a hydrogen, and we're gonna get the following compound. So we're gonna get an activated formaldehyde molecule. Now what happens next is catechol is gonna come in. Catechol is gonna come in with one of the hydroxides and kind of push those electrons to the OH. They're like, nope, OH, you're positive, I'm gonna take on that burden. They play kind of hot potato. So what happens next is we get an OH. I forgot how to draw benzene for a second. That was awful. So we have this molecule here, and we see that there's a positive charge. So what is most likely to happen? Well, another catechol molecule is going to come in with one of its OHs, and we know that a positive charge could be reduced by this. So we're going to take that there, and let me just make sure you guys can see. Of course you guys can see that far. That's wonderful. Okay, so we get this molecule here. Now, this is a hemiacetal so far. The hemiacetal is right there. So the next step is to make a full acetal through the removal of this group. So simply H2SO4 comes right back to provide a proton, and we're going to get the following compound. Now this carbon is ready to, or sorry, not this carbon, this oxygen, this alcohol is ready to leave. So we need something to kick it off, and that's where we're going to get the cyclic nature. This OH is going to come around, bam, kick that water right off, and that's exactly what happens. It comes wham, kicks off the water. So we lose a water molecule here, and we're going to get this molecule here. So and the last step is just to deprotonate our group here. So we just take another catechol molecule, catechol comes in, and we're gonna get our final product, and I'll just draw it as how it would be presented in a book or something. We get this. So we have a 3-membered ring intermediate here, or not an intermediate product. connected to our benzene ring. That is the product that we get when we react this with formaldehyde. So if we were to draw the product given the mechanism we just have drawn, it would look something like that. Thank you guys so much for watching. I hope you learned something today. If you did, drop a like, drop a comment. If you have any questions, I would love to answer them. Have a wonderful day.